right. So let's get started. Volt az első slide? Az oké. Nem, sajnos. Oké. És presenter mód. Cool. Jó. Okay. So, hey everyone, and thanks for joining today for the launch party of SchemaMap.io. I've been working on my startup for 1.5 years. It's been a long journey, one soft launch so far, and this is the second. Let's hope this goes better. So SchemaMap is a data ingestion platform for Postgres-based enterprise applications. It inspects their database to provide instant batch data import, so you don't need to develop or maintain it. So for the people in the audience who don't know me, I'm Chris. I spent 7 years at Ekata, which is a global identity verification company. And I've been a team lead, principal engineer, was part of a cloud migrations, SOC Type 2 certifications. So it was a really good start to my career with a nice exit at the end. And I put AI in production before it was cool. That was the identity check product. So if you have a MasterCard in your pocket at the moment and your identity gets stolen or the details of your credit cards get stolen, I'm protecting you. So you're welcome. After that, I moved to Switzerland, where I was tasked to make an ERP system from scratch in 1 year. So that wasn't too easy. But in the end, with some technological choices, we managed with just a team of 5 to create from the first line of code to fully onboarding the first customer in 16 months to develop the system. So this is called Mythico. And during that development journey, where I was mostly involved with system architecture to enable this insane speed of development, the data onboarding was the most painful. So once I moved back to Hungary then I realized that this is something that I really wanted to solve. And the real problem was that even though people are working on AGI and OpenAI and everything new hot stuff, we don't really have a way to completely fill existing production databases with some new data. So ambitious businesses that tackle complex problems necessarily have large databases, but they become slower and slower, and you feel sluggish after a while just because of the complexity of how hard it is to understand these systems. Yes. So what is the landscape, and how could we achieve this kind of development velocity? We used the instant data API solutions that we had. Examples are Supabase and Hasura. And these tools, existing tools, allow teams to define their domain of what they are solving and then get automatic selection of data from their system and putting in new data. But the problem is they kind of fall off after a while. Let's say you want to populate more than a handful of tables, you just hit limits. It times out, you can't really express what you want to do. So then you enter the valley of despair, which is download this Excel template. Python scripts to, in 5,000 lines of code, fill 400 tables. It's terrible. It takes a really long time, and it's a maintenance burden, because even though you write a one-off solution with the next customer, with the next onboarding that you need to do, you will have to reuse that, and you get slight variations all over again. So, but once you reach the end, or you get the full database restores, you kind of like fix the problem. But in the middle, you don't really have a solution. So why is this so hard, and why is there no existing proper solution? Because you have to consider the full database that you have, which really, if it's properly modeled, it describes the whole application that you built on top of it. So every single arrow you see, which is just a big mess, you have to take care of that. And manually specifying these details in code is what leads to brittle solutions, because systems change over time. And then you start out with just a simple MVP. Then you start to, let's do product groups. Okay, so one product can belong to a single product group. You can imagine how the UI changes with all of that. Then a few sprints later, that's too limiting. We want to enable a larger scope system. We want to be more ambitious and model things differently. And this just goes on and on. So the only winning move here is to not play, which is to say no. And if you have ambitious systems and you want to really build something that encapsulates the world, you will just have to live with the complexity that these decisions bring you. So what is the solution? First of all, we have to understand this mess. Because if we don't understand all of it, we can do nothing. So for that, Schema Map offers a two-step solution. First is an open source SDK available on GitHub that you can install into your Postgres database. So it describes the complexity and allows you to talk about all of this. And that's all for free. That the goal is to allow complex systems to be easily described, which is missing outside of enterprise tooling, and it's an underserved market. Once you do this in your database, you can connect it to a dashboard that tracks this whole mess, the schema of your database over time. So this gives you insights whether what you think you are building and what you are actually building are diverging. This leads to data issues, and it's a mess if you don't track it correctly. Mostly medium-sized businesses start using data governance tools to get this, and this is a free offering that you can start using today. Okay, so you describe now, and you have a tight grip over how your expectations about your system evolve over time. Well, the reason why people don't do it today is because there is no reward. You don't get anything out of it. You are just describing a system for no benefit. Schema Map offers, in two different tiers, a reward for this endeavor, which is you get automatic data imports. So what you can do is never have to write any of that messy codes again, and you don't have to maintain it. For that, there is a software as a service offering which does the necessary work for you, and it's only charged on a usage basis. And for companies that don't allow any outside connection, there is a self-hosted yearly license solution that you can get and use also for local development. So the first part of the solution looks like this. You get a nice dashboard. You see how large the system is. You see how constrained it is. So you can tell a KPI is we should be really constraining our systems more so we can tell what is correct and where we are not meeting the expectations for our applications. And these are tracked over time. You can compare your expectations from the past to now. You also get a human understanding of what you are building, and you get separate descriptions of all of these interrelated concepts and how to actually import data into it, which is hidden usually in these large diagrams that don't really tell you much. And then the reward is that you can write very high-level descriptions of what you want to happen. In this case, copying from my local database projects, environments, and a few tables into a production system in a way that's safe, repeatable, and instantaneous. So, yeah, I've been bootstrapping this for a while. So, and the go-to-market strategies that have worked for me in the open source section, which is the Postgres SDK. I've been including this SDK into developer tooling. So from day one, instead of when you have hit product market fit or later, you already have the necessary framework to manage this complexity that you are going to build. For small, medium businesses, Reddit outreach help a lot. So I've been active in the community, especially in the Postgres subreddit, and that led to a pretty good click-through rate. This is like almost double of what the industry standard is. And since this is the launch of the product, I'm planning to start now blogging about how to improve the schemas of databases, so there is less pain for everyone involved, and planning to start content marketing on top of this. For the enterprise, you will be able to find me at most Postgres conferences, and yeah, next week I'm going to Athens for the largest Postgres conference. So planning to make some partnerships with backend as a service providers for Postgres databases. So right now, at launch time, I already have 4 companies integrated into the system. One of them is a CRM. The main benefit that they got already from this is that once they get demo signups for their test system, they don't need to write manual cloning code. They can just create a custom-made quick demo data set. So if company X joins, it already looks like something that they would have. So this really helps their sales process. I have an ERP system, which I developed. You can tell it's Mythico. They use it that if production system gets 2,000 new products added because something changed, they can, within 5 seconds, copy all of that data over to the staging or pre-test environments, and they can easily replicate bugs that happen there. This also, since this is sync in 2 ways, they also do pre-production code that they test out new features, and once they go live and the schema changes, they can backfill the production system with what they did, so they don't have to enter it on production again. I also have a healthcare system integrated, and while looking at the statistics to understand what the domain complexity is, we have seen differences in what the healthcare domain is about and how it was modeled. So it improved the state of the system. And of course, I use it for myself. So if I have any bugs or any kind of issues, I can easily replicate. I can just copy from production a sanitized dump of the database at any time. Okay. So what are some unique insights that I've learned about building this, and also while bootstrapping, consulting with companies? The first is that your database tells the story of your application. And and what my issue was that if your database is ambitious enough and it doesn't look like this, it already tells me the story that it's under constraint, and it's probably going to be affected by bugs of data consistency. And then the second is that every database, including mine, is under constraint, because it's just not rewarding to specify what is the definition of correct data. Most of current setups of frameworks and service providers don't reward you for specifying what is correct. So what is a system and who is the person that takes a lot of data that has been underspecified and makes something with it? A data scientist. So you can kind of bring the definition sooner, do a bit of more homework, and that's my primary KPI for my customers, that over time they constrain their system more because they get value out of it. And then the final insight is that just like the existing instant API tooling, deterministic API inference, which in this case is large amounts of data entering hundreds of tables, is superior to handwritten code because it doesn't need to be maintained, but also it also increases your understanding of the system, because if you see a large data set that you can play with and put into an actual production system, you get a way better understanding of what is important and what is not. So it actually aids in the understanding of what system you're onboarding onto. And since you eliminated programming languages, distributed systems, all these tools that you normally would use for this problem, you eliminate all kinds of complexity, untested code, etc. You can give that to a system that handles this schema map, and you get the benefits of it. So I'm looking for early adopters. There is a Discord you can join. I'm happy to help with schema-related concerns, and you can reach me at the email address. So, yeah, that was it. Any questions? Yes, Arti? In English, por favor.
I know that like startups have feature creep.
Mm-hmm.
So my database has like PII in it.
Mm-hmm.
And it's nice that you have a self-hosted version
Mm-hmm.
that I can just run on my system. But is there a way for me to like pseudonymize, hopefully, or at least anonymize my production database so
Yes.
that I can bring it back for debugging?
Yes, exactly. So I hope the the mic picked that up. To summarize it, is there a way for, once the movement of data happens, to anonymize the sensitive data automatically? Yes. But that's already an existing problem, that people underspecify their system. So you have a database with 3,000 columns. Where is the PII?
I can tell you like which columns have PII.
Yes. Yeah, maybe you can tell it, but not automatically. Let's say a new joiner. So we will be taking an example integration of what all of this means. So let me just quickly change the displays so you see what I see. No. 1 second. Mirror. Yes. Okay. So you should be seeing what I see. Let's check OBS. That looks good. Perfect. So, so I will show you an example application. I've looked around on the internet of a well-modeled, open-source, Postgres-based, ambitious application that takes, a huge chunk of enterprise application scope, which is what you usually get after a few years of development and is kind of the ideal customer profile of Schema Map. So let's check out Odoo. So Odoo is an open source CRM and ERP and a few more applications. This column is just SAP, so you can already tell. It has an HR system, a dashboard, timesheets, everything. You can run your company on it. And the nice thing is, it's just Postgres. So, and it even has an open source, fully open source schema. So despite them sharing the structure of their system with everybody in the world, they still did $900 million in revenue this year. So pretty impressive. Of course, you can see where I'm getting at. So business scope, SAP at the top, and Odoo here. and Slack is comparatively simpler, let's say, than SAP. So I'm definitely targeting people on companies in this quadrant or 2 quadrants. Cool. So let's assume that we are now it will be a bit more technical. So let's assume that we just joined Odoo as a developer of a company, and we saw this presentation and we think this might be a good idea to understand the system. So this is, by the way, available on GitHub in the schema map public repository, so you can try out schema map for yourself with this open source data without sharing any data from your actual system. So it's a nice example. So what is the software architecture for this? We have Postgres 15. This was taken from the Odoo tutorial. No changes have been made. And Odoo has a Python web server connecting to Postgres. And then we now initialize the database. So you kind of have to initialize that manually by passing a few parameters. So now we should be running. Cool. Is this large enough? I hope yes. So we log in. And we see tons of features that we can start to enable. This is a very common approach that you pay per module. You kind of enable the complexity that you have. Cool. So we have a working system. Let's see how schema map fits into it. So you sign up to schema map, totally free. You choose the correct tenant, and then you make a project. Let's do Odoo test. Cool. So now you can switch over. So schema map handles multiple companies, and within a company you can have multiple projects. So if you're a software consultancy, you can have an overview across all of your projects that use Postgres. So let's switch over, and if I go, oh yeah, I forgot. Let's also create some environments where Odoo can exist in. By default, when you sign up, you get a local environment specific to a user, and you get a staging and production, assuming you have at least production. Okay, so this is where you would usually end up. And I highly, highly recommend setting up the local environment first so you can try out the feature sets. But of course, you can run the same thing on different environments. Yeah, let's start locally. So you get a simple one-liner install that, since it's Mac OS, it's most convenient to install from brew. Okay, so what happened? We installed the code and then ran schema map init. And schema map tries to be easy to use. So let's make this a bit smaller. Opa, that's a bit too small. Okay, so it automatically found the Docker Compose YAML file and found the Postgres service in it, and correctly inferred the port that it's using, the user it's using, but sadly, in the YAML file there is a different database specified. But it still went ahead and installed the SDK into the Postgres database. It created a set of users that will be used to connect to the database and provide the batch data. And it created a schema map schema in the DB, which will be used to store any temporary files. Cool. And then at the end, it, of course, grants the necessary rights to be able to use the system. And then with the open source SDK, you get a database snapshotting tool, because again, schema map turns the problem of having multiple versions of your databases in different environments into an asset, because now instead of having to copy the whole database, you can take parts of it and shift it around. So it is kind of it makes it easy to have this kind of database setup. Cool. So by saying yes, I created a new database in the local system called schema map dev. And to drive my point home of the database describes what the application is, well, it stores a snapshot. So I just logged into schema map dev database. And what I will do now is, I see that the Odoo test database is what has the actual data. So now I will create a snapshot from that to have multiple versions of the same database. So let's call this baseline. Cool. So without any CLI, with using the SDK, the development time SDK, I created a new DB, which is sourced from the test database. We will use this to now create a few more versions so we can simulate how schema map works by shifting data around. So now I have a snapshot, and I will create a CRM database and a sales database. Cool. So now if I go back to Odoo and log out, actually Odoo implements this same feature through a web UI. If you use schema map, you don't need to develop this feature at all. You just connect to the schema map dev database and copy the necessary, make the snapshots yourself. So you automatically get this. Okay, so let's install the sales features in the sales database. So what this does, in the lower right you can see it's loading. It actually is putting the necessary data schema into the DB at the moment. That's why it's taking a bit longer. And while this is happening, let's log out, switch to the CRM database, log in, admin, and search for CRM and activate that. So now we have two separate systems running on my machine. One has the basic set of expectations from the user and the application with sales added, and the other has CRM. So now if I go here, I get CRM, I see my qualified leads, my propositions, my won deals. And if I go here, I should see my sales dashboard once I log back in again. Sales dashboard, admin. So this is kind of like the same system, but in two separate states where you have the basic setup the same, but you have two different extensions separately. Okay, so let's now install the schema map SDK into the correct databases. So you just specify Odoo CRM. We don't want the snapshotting since it's already done, and we want the sales. Great. Now we can go and continue the setup process since we did this. And since normally if you use the SaaS offering, you are connecting over the internet to schema map. So schema map will provide you the data. So for that you need either an SSL connection that you can whitelist. This is mostly for staging and production environments, or you can reserve a secure tunnel. Done. You get a port assigned only for you for this specific project. So it's kind of like ngrok or local tunnel. It's for you only. So you can download this file, and then it tells you, hey, you should run this command once you got the secrets that are necessary to set up the tunnel. So I will just copy that over. Cool. So if you name it against your own user, then you can just type schema map up. Okay, so now I started a peer-to-peer encrypted tunnel of my local database. And yep. So now if I come down, let's do the checkbox. We can connect securely, and we can connect with a lower privileged user. So let's connect first, let's say with the Odoo CRM. Yeah, of course. I forgot a step, which is we don't have the Postgres port on the normal port. So 1 second. Sorry. What is it? 8453. Okay. So now we are exposing the correct port, which is not the standard. And now this should connect. Yes, good. Okay. So now we have schema map, the platform, can connect to my local database to the CRM data. So what does that give me? Well, automatically you get insights into what the database is about. It's 260 tables, 2,500 columns. So if you were to write some code that needs to populate this database, you should be needing to specify 2,000. You need to do 2,500 decisions essentially. Then you get some extra analysis on top, which is you remember the spaghetti of all the different tables, how they fit together. Well, what this tells me is that there is actually one huge blob of interconnected tables, and there is 258 of them. And the way that you actually start filling this data with any kind of data, there is the sequence of steps that you need to do to actually do that. So you have to fill the countries, and then you can add the partners that you have, and then you need to add the users. And whatever you do, whatever language you will use, these are the steps that you need to manually, with your knowledge, decide and do. So there is no tool at the moment that deciphers these decisions for you. So this is, again, completely free. So you can just take all of these, copy paste it into a seed SQL file, and have at it, and then fill the values section with whatever you have. So, and this is the point where we start crossing into the benefit section. But to actually fully demonstrate, I will add the second data source. So you can see that I have the CRM one. And if I come down here, I can just say that I want to do the sales one. Yeah. Cool. So now if we go back to the schema overview, you can decide to inspect what the sales system was. And schema map tracks over time how the system changes. You see, now the sales, now you can already tell, the sales system is quite a bit more complex. It's 362 tables, and it doesn't even start with the same data. So, despite having a single system, by having it in two separate states, you have to understand both of those to be able to actually populate it with data, which limits you in onboarding, etc. So, yeah, cool. So let's start shifting data around, which is currently the implemented data source to actually shift from one database. You can take one of your databases and whatever is in it, and then put it into another one without resetting, without any kind of destructive action. So let's copy, let's say, the users table from the CRM system. Again, this could be production, staging, any kind, to the sales system. Okay, so what's happening right now is schema map checks both of those schemas, all of the 300 plus tables, figures out what is needed to actually do this data movement in a way that's safe, repeatable, and well, instant is a stretch, but it takes a bit of time to compute it and also to visualize it. And it came up with this plan. So this was kind of like a constraint solving solution where it used the knowledge that your SQL dashboard writer person or your most competent backend person will use, and it came up with a plan that achieves that goal. Yeah, so you can see on the source side, we see that we don't have select writes on the tables. So by default, when you install the schema, even you don't get any data read writes. So we will fix that in a second. But despite that, it already knows the structure of your DB and the interconnections. So despite only specifying users, it also would like to copy over some of the parts of these other tables to be able to do the job. Why? Because on the target database side, there are the same tables, and while we only want to copy over the users from this system to that system, we need to find the matching companies, partners, and teams. So in a more visual way, there is a copy happening from the users. It goes into a temporary table on the target database side, and then schema map cannot insert data, but it will generate a way to actually do the necessary job. So now, if I click syncing, yeah, I don't have select privilege. That's fine, because what should happen now? Well, of course, data won't actually be moved over, but yeah, cool. So we see that we got the data migration was loaded. Not much data went over the wire, 0 records and 0 megabytes. But now you should start to see why the SDK is necessary, because on the target database side, DM stands for data migration. The first data migration happened into the system, and you got an import function that actually you can run this with any user that has the permissions to do the necessary load. So this generated 7 functions that you would have needed to write yourself, and 4 tables. And of course, while copying these tables, there was a permission error. So this is kind of the default state. Schema map, even if you connect it, cannot read any data. It's not that useful, but it's safe. So, so let's go and fix that. So I specify the CRM database. Yes. Cool. So now we are connected to that, and since you can see the separate users that the SDK installed, and we connected with the schema map one. So let's actually, they are in a hierarchy. So schema read is the default, and that's all you have. And then you have read only, which inherits the schema read permissions. And then you have the read write. If you allow schema map to actually do the migration, you can assign to that. And the top level user is what you get by default, and that's what you normally automatically connect with. So it allows like a gradual, as your confidence increases that schema map doesn't do anything nasty with your data, you can gradually keep increasing what it is allowed to do. So now we will be very permissive and allow read only to read from all the tables. So now if we go back, of course you can use row level security, any kind of Postgres level features to constrain what it can look at. Okay, again it's going to take a while. Yeah, but that's kind of the point, that resetting a database is kind of like the failure of computer science. that we shouldn't be destroying information just because our expectations are a bit different. Yeah, so now we can migrate information over. So you can see that now we get actually estimates for what is going to be copied over. So even though we only have, by the way, you can specify this also in SQL. Even though we have only one user, we will check the lookup in those other databases. So now we can sync it. And now we get a second data migration, which are just sitting there and not doing anything. And you can build a UI on top of it. You can charge your customers for this kind of movement. And you don't, it's a part of your system. You own it, but I provide it. So cool. Now we have data migration 2. In this case, I copied over 53 records. So now if I go to the sales database, and I'm currently the audio user, which owns the solution. That's good. Again, just to reiterate, permission denied. Schema map as a platform by default cannot modify your system. It cannot mess the data up. Okay. So now if we go back to the user that can actually do the change, then okay, this generated some code that you probably don't trust. But since everything has been already localized to your database, there is a solution to run untrusted code in your DB, and that's called a transaction. So you can run the import. It gives you the details of. Okay, what happened? Just a sec. Let's roll that back because we didn't like what we saw. Cool. Okay, cool. So now you see that the import function actually internally does the necessary steps in sequence. So it looked up all the teams. So if I check this, well, it found, because the teams don't really have a meaning, what is the same team in some other system, Schema Map decided to just use ID equivalence. If you had a unique constraint on the teams, that there is only a single team named X, then it would have copied over the column here. Let's check if that, if you have specified the schema good enough. But I guess, oh, here. Good. So it seems companies are unique by name, so they have meaning. And it found my company. So this could have been any other number, 42, and it would have found the company in this system with the same name. So if I check REST company, oh my God, too big. Then, okay, yeah, so Schema Map compiled the necessary code to find the equivalent records. So at least for the company, you can just shift data over and not have to deal with referential integrity. So I'm now kind of happy with the solution. So in the end, it inserted 7 users. It doesn't upsert automatically, so these users probably already existed. But that's kind of the minimum case that you can do. Yeah. So that's the basic setup of it. If you, just to wrap things up, what you can also do, you can, if you have built a multi-tenant system, you can teach Schema Map about how you do that. And the way you do that is by running Schema Map Doctor. It tells you about any kind of issues or improvements that you can make to the integration. So you can copy paste this code, which is updating the listing of tenants in this database. You can add this to your own migrations, and you can teach with a select query how you have, where is your tenant? If you have like a tenant ID or organization ID, etc., you just say, okay, what are the primary keys? What is the short name? What is the name that could be displayed? What is the language of the tenant? And Schema Map will take this definition and will figure out the necessary details to actually scope your data migrations to a specific tenant. So this is my own local database right now. And if let's say I want to copy the projects, which you see here. Then these 2 projects belong to me. And let's say I want to copy it to production. This should be way faster since I have a smaller system. Good. Then schema map automatically figured out that projects has a foreign key reference to the tenant system, and it took this nice product manager compatible idea of we have tenants into the necessary SQL where clause, and it will get applied. So we only have, and this is again just an estimate. This is off by 1 at the moment, but if you have thousands of tables, it uses the analyze query planner to figure out what would be the amount of records that would be transferred this way. So I can now, against my live production database, again, I only specified I only want to copy the projects I have, but the tenants need to be looked up. So let's run that. And again, this is a oversimplification. This is the reality that you have to contend with. So if you have different columns, if you have different types, it will normalize everything to the target database schema. And then here are the temporary tables that you have. And this is kind of the nice scenario. So you see that in the source database, this, let's say, is 42. All of these get collected into a lookup table. What is the name of, or what is the slug of 42? Schema map IO. And then in this new database, it's 69. And then that is the value that actually gets filled to have the proper reference. This is shown for simple data migrations like this one. This is kind of the simplest. If you have hundreds of tables, it doesn't get rendered. You only see the nice and simple arrows go from one DB to another. But all of this complexity is managed for you, and it just works. Yep, I think that's it for now. So any questions? Cool, then that's it. Thank you very much. Let's grab a drink.